We're going to be going over motion word problems. Although when you first read them, they seem to be confusing, once you learn how to set up a chart, they become really easy to solve. The first thing you need to do is to make a chart. All that we'll be using now are using distance equals rate times time. This is the standard formula for distance. And then beneath it on the left-hand side, you're going to label whatever it may be. Vehicle 1, Vehicle 2. It could be airplanes, cars, boats, people, whatever it is, but give yourself enough of a definition so that you understand what it is. It may be really brief. It might be slower car, faster car, airplane, jet propeller, whatever it is, so that you understand what it is. The goal of filling this in is to give you the information so that you can write your equations to solve it. There are three types of distance problems, and we're going to start with distance first. The first one is both cars are going in the same direction, but one goes further. In this one, the standard question they ask you is, at what time did car number 2 end up 15 miles further than car number 1? That would be an example. Now, number 2 is two cars going in the opposite direction. This would be something as both cars leave the square plaza at the same time and they travel in opposite directions. How long does it take before they are 150 miles apart? The third type of distance problem is one car or vehicle, whatever it may be, going in one direction and then returning to its starting position. It may be the plane flew to Idaho with a tailwind of 20 miles an hour and flew back with a headwind of 20 miles an hour. That sort of problem. Let's look at the first scenario, when the distance is not the same. So when you're setting up your chart, you can set, it doesn't matter which one you set, but set car 1 as the distance, the shorter distance. Make that your first line. So the second vehicle goes the distance of the first vehicle and then further. Well, I put plus question mark because you're going to have to read the problem to see how much further the second vehicle goes. Then read for what they put for rate and time for both vehicles, fill in the chart, and then you're going to have two equations. Distance equals R1 times T1, and for the second vehicle, distance plus however further the distance is equals R2 times T2. Well, now you have a system of equations that you can solve. The easiest way is probably substitution, and since the first equation you know what D solves for, place that into the second equation and solve. Now when you have cars going in the opposite direction, you're actually going to have just one equation. This is happening because the distance is going to be the accumulation of what both vehicles go. They're both going in a straight line starting at the center, and the question will be, how long did it take both cars to get 150 miles apart? So in order to figure out that, it's the distance of what car 1 went. Well, we know distance is rate times time, plus the distance of what car 2 went, which is rate 2 times time 2. That's why when you have them going in opposite directions, take the distance that they need to be apart when it needs to be solved, what I'm calling your distance given, equals R1 times T1 plus R2 times T2. I'm not going to give examples for each one of these problems, just due to the time limitation that YouTube gives me, but go to your textbooks when you have problems and go back to whatever slide you need to. What type of problem is it? And go to that slide. The next one is going from one point a distance and then returning back to that same point. Well, the distance is going to be the same for both of them, so put D in for both for your distance. then you're going to have to read the problem to figure out what else to set in. Since the distance is going to be the same, the rates are going to have to be different. It normally will be with a headwind or a tailwind. So if it's with a tailwind, it's pushing you along, so you're going to go faster. So it's going to be rate plus whatever the tailwind is. If it's a headwind, that's slowing you down. So it will be R minus the headwind. Now, that's if we're talking about airspeed. If we're talking about boats in the water or something like that, well, with the current is going to be plus however fast the current is, and then when you're going against the current, it's going to be minus whatever that current is. So set up your rates, and then once again, you'll have two systems of equations, and the easiest way, since they're both set for D, just take one, set it equal to the opposite one, and then solve your equations. Now, look what happens when time is different. Okay, so they're going to give you your distances, they're going to give you your rates, but your times are going to be different. Set one vehicle, whichever one you want, to time t. Now, the second equation is either going to be less time or more time. That's why I put the plus minus sign. We don't know what it is, and we don't know how much shorter or faster the time is. You're going to have to read the problem, put those in, fill in for distances, fill in for the rates that they give you. Once again, read across. Each line will be an equation, then you'll have two equations, which is a systems of equation, and then solve it. Let's look at when the rates are different. And as I said before, this is when I talked earlier about when the distance is going to be the same. Okay, since they're going to be the same, set each distance equal to D. That we know. But the rates are going to change. So the one that has a tailwind is going to push you, or it may say with the current. That is going to be pushing you. So you add whatever that is. So that would be your rate plus whatever it was. If it's going against you and slowing you down, that's going to be a minus. So if you have a headwind, that's going to slow you down. So that would be minus X. If you're going against the current, that would be minus X. Now, the time for these can be equal, but they're usually different. So you're going to have to read the problem to fill it in. In summary, make a chart and pull the information out of the word problem to fill in the chart. When you do that, you only have two possible scenarios that you could have. One is there only be one equation. That is if the two vehicles combined give you one distance. You're starting at one point, going opposite directions, and they want to find out when the two are 150 miles apart. And the second one, you will get two equations, then you will solve them as a system of equation. Remember, each equation is going to be a row on your chart. Good luck, all.